In this video, we're going to cover extreme programming, one of the most successful agile methodologies. Here's the extreme programming model as illustrated by Pressman. Now, I'm not a big fan of a lot of Pressman's process diagrams. They're usually pretty oversimplified, but I think this one is fairly reasonable. Maybe I would replace planning with requirements here, but I think this does convey the big picture. Let's go through each of these steps individually. An increment begins with requirements gathering, which is what the user stories here are referring to. The idea is that you ask the customers and potential users to come up with stories or scenarios about how someone would use the system. These stories then become your requirements. The customer will assign a value to each story, which is their priority for which stories are the most important to them. Then the developers assign a cost to each story, which is how long the story will take to implement. With this information, customers and developers meet and agree on an increment and a delivery date. At the end of that increment, usually 2 to 3 weeks, the team looks at how good their estimations were. In other words, were they able to deliver the appropriate code in the correct amount of time? And then they try to adjust their estimates accordingly for the next increment. XP design encourages the use of class responsibility collaboration, or CRC cards. What's a CRC card? Well, a CRC card is one of the simplest designs you can do. Extreme programming, and indeed most agile methods, is associated with object-oriented programming. In object-oriented programming, you create classes, and classes encapsulate an object's data with the operations that manipulate that data. A CRC card is simply an index card that represents a class in the code. The responsibilities of the class are a high-level abstraction of what the class is supposed to do. Many of these will turn into methods, and the collaborators for each responsibility are the other classes involved in a particular responsibility. In this example, the order class has the responsibility of checking if a number of items are in stock, and it will need help from an order line object to make that determination. Maybe the order line objects hold the name of the item and the number of that item that the customer wants. If there is a difficult design problem, a spike solution or design prototype is created. The term spike solution often refers to any prototype in XP, not just a design prototype, but a prototype to help evaluate requirements as well. Finally, XP encourages refactoring, which is a refinement of the program design. Refactoring is an interesting concept that we're going to look at in detail in this course. Based on the definition given here, do you think you can tell me what changes when you refactor and what stays the same? I know this is a general question, but see if you can take a minute and come up with a reasonable answer, and then I'll give you kind of a clever answer. Ready? One of the obvious things that changes, just based on the definition that we saw, is the design of the code. But what does that mean, the design of the code? Does that mean that the code itself changes? The answer is absolutely. Changing the design of the code is going to cause the code itself to change. So the code will change. Now, what are some of the things that will not change? Well, something that you might think changes but does not is the performance. Refactoring is not optimization. In fact, refactoring may cause the code to have worse performance. The point is that performance is not something you should think about when you're refactoring your code. The most important thing that does not change is the functionality or the behavior of the code. After refactoring, the code should do exactly what it did before refactoring. Therefore, refactoring is not debugging. You should only be refactoring code that already works. Okay, so what's the clever way to think about this? Well, it's this. Refactoring doesn't change what the code does, but it does change how the code does it. And it does this in such a way that it strengthens the design of the code. Finally, coding and testing in extreme programming are very intertwined. XP recommends that unit tests, which are tests for individual components, are written before you start coding. This is known as test-driven development, and even folks who are enthusiastic about the benefits of unit testing can find this difficult to do. Unit tests are executed daily. Some of them may be run every few minutes. Pair programming is also something extreme programming encourages, and you might even say that extreme programming made it famous, though it existed a long time before extreme programming did. In pair programming, one person programs while the other looks over their shoulder and helps catch mistakes. Every so often, they switch places. This is a good way of getting instant feedback on your work. Acceptance tests are different from unit tests. They're defined by the customer, and they're meant to test the requirements or the user stories that were created in the planning stage. All of the phases here are repeated in each iteration again and again until the customer has a product that they feel is ready for release. I'll leave you with this image from the Extreme Programming website. This is a clever depiction of the times that various activities will take in extreme programming. Pair programming is something that's more or less continuous. Unit testing is conducted every few minutes. Pair negotiation might happen when the two programmers have different ideas on how to proceed with a design issue. Stand-up meetings occur every day. Acceptance tests take place every few days. An iteration plan occurs every few weeks, and a release plan might occur every few months. Okay, that concludes this video on extreme programming. I hope you found it interesting. In the next video, we'll talk about another agile development methodology that has become arguably more popular than extreme programming, and that is Scrum.